Namaste student. Today I am going to explain a new chapter, that is S block elements. S block elements divides into I divided into two parts, that is part 1 and part 2. Part 1 contains alkali metals, part 2 contains alkaline earth metals. So welcome to chemistry class. Now, what is the meaning of S block elements? I already defined in the previous chapter, that is in the classification of periodic tables. In that I already explained what is the definition of S block. Still again I will explain what is the meaning of or what is the definition of S block. S block elements are those elements in which the last electron or valence electrons enter into the s orbital of the outermost shell. Enter into the s orbital of the outermost shell. So based on that, what is the general electronic configuration? It can be written as noble gas ns1 to 2. Okay, so last electron enter into the s orbital of the outermost shell. Okay, so see here, I already told that S block elements contains two groups, group 1 and group 2. Group 1 and group 2, that is group 1 it is called as alkali metals, group 2 called as alkaline earth metals. So group 1 elements, it is I have written on the slide: lithium, sodium, potassium, rubidium, cesium, francium. Okay, I will repeat it again. Group 1, that is called as alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. Francium is a radioactive element. That is a very important question. Question will be asked. Name the radioactive element of alkali metals. So answer is francium. Okay. So the next part, alkaline earth metals. Okay, group 2 elements are called as alkaline earth metals. That means maximum elements are found in earth crust. That's why it is called as alkaline earth metals. Okay, so the elements are beryllium, magnesium, calcium, strontium, barium and radon. Okay, we'll move to the group 1 elements, that is alkali metals. Okay, so group 1 elements I already named as lithium, sodium, potassium, rubidium, cesium and francium. Since alkali metals are most reactive metals, metals or elements, okay, these elements do not exist in a free state. Okay, do not exist in a free state or elemental state. Always exist in the form of a combined state. Always exist in the form of ore. Okay, ore or minerals. So and then sodium and potassium abundant in nature. Okay, lithium, rubidium, cesium less abundant. Francium, of course, it is a radioactive element. So this is about the occurrence of alkali metals. Now these group 1 elements, why it is called as alkali metals? That is a question. Okay, so because they are oxides and hydroxides. Suppose if I take sodium oxide or lithium oxide or potassium oxide. Same way hydroxide in the sense lithium hydroxide or sodium hydroxide or potassium hydroxide dissolve in water. Okay, it will dissolve in water, giving highly alkaline solutions. That's why it is called as alkali metals. Okay, when it is dissolved, that means oxides and hydroxides of alkali metals, when it is dissolved in water, it will give alkaline solution. Now alkaline solution means when you touch the alkaline solution, you feel like soap. When you touch the soap, okay, soapy touchness is there when you touch the alkaline solutions. So that's why group 1 elements are called as alkali metals. So this is also very important questions. question, that is why group 1 elements are called as alkali metals. Because their oxides and hydroxides, when dissolved in water, it gives that solution is alkaline in nature. Okay, what is identification of alkaline solutions? While when you touch the alkaline solution, how you feel? It is you feel like a soap water. Okay, you feel like a soapy touch. Okay, so of course I already told that they have one electron in their outermost shell. Okay, one electron in the outermost shell with the characteristic of electronic configuration, that is noble gas NS1. This you already studied. Okay, so the next part, it is characteristic properties. Now we'll study one by one what are the characteristic properties. So first one, of course, a very important concept, that is a electronic configuration. That is electronic configuration. Okay, so here you can see this, see the table. So one by one I have written lithium. What is the symbol of lithium? It is Li. Sodium, it is Na. Potassium, K. Rubidium, Rb. Cesium, Cs. Francium, Fr. Okay, so francium is a radioactive element. See, you can see the atomic number. So based on the atomic number, if you write the electronic configuration, see here 1s2 for lithium, 1s2, 2s1. Okay, so this configuration we can written like this also. That is a, what is the general electronic configuration? How it is written? Noble gas NS1. So based on that, noble gas. So which noble gas comes? That is a noble gas. It is a helium. Okay, helium atomic number is 2. So next to helium it is a lithium. So that's why it is written as a helium 2s1. Helium 2s1. Okay, and sodium atomic number is 11. So electronic configuration is 1s2, 2s2, 2p6, 3s1. This configuration you can write like this also. That is a noble gas NS1. So which is a noble gas? That is a noble gas or rare gas. It is a neon. Okay, neon atomic number is 10. So after neon, sodium comes as a 3s1. So like this we can write even for potassium, rubidium, cesium and francium. Okay, so based on that electronic configuration, general electronic configuration of a group 1 element is, it is written as noble gas. Okay, NS1. So here you can see outermost shell. It contains NS, 2s, 3s, 4s, 5s, 6s and 7s. And in that how many electrons are filled? It contains only one electron. Okay, only one electron. So based on that it is written as a NS1. I hope you understood the concept. Okay, so we'll move to the next property. The next property, it is atomic radii and ionic radii. So I already explained what is the definition of atomic radii and ionic radii. Atomic radius means it is nothing but a distance between the center of the nucleus, okay, to the outermost shell. Center of the nucleus to the outermost shell. So that is a definition for atomic radius. This is already explained in the classification of the periodic table. So so how it varies, atomic radii. Now we'll apply atomic radii or ionic radii concept to the to alkali metals. Now alkali metals, in general alkali metal atoms are biggest in size. Okay, alkali metal atoms are biggest in size, that is in generally, okay, compared to other elements which is present in the periodic table, okay, like P block or F block and D block. When we compare to these block elements, usually alkali metals are bigger in size. Okay, now what happened down the group with respect to group 1? With respect to group 1 elements. Now group 1 elements means what and all elements includes, that is from lithium, sodium, potassium, rubidium, cesium and of course it is a francium. Okay, so when we move from top to bottom, Okay, when we move from top to bottom, what happened here? As atomic number increases, that you already observed electronic configuration 3, 11, like that it will go. Okay, atomic number of lithium is 3, sodium is 11, potassium is 19, like that it will go. So what happened? As atomic number increases, shell number is also increases. So addition of shells takes place. Addition of cells takes place. So atomic radius and as well as ionic radii is also increases from top to bottom. Okay, next, that is a next property. It is ionization enthalpy. Ionization enthalpy or ionization energy. Now, what is the definition of ionization energy or ionization enthalpy? This is also I already explained in the chapter 3, that is a classification of a periodic table. Okay, so ionization enthalpy means it is nothing but a amount of energy is required to remove the electron from the outermost shell. I will repeat it again. Ionization enthalpy means it is nothing but a amount of energy is required. For what it is required to remove the electron from the outermost shell. Okay, so this is the definition of ionization enthalpy. Now we'll apply ionization enthalpy concept to the alkali metals, that is for the group 1 elements. Okay, now alkali metals have low ionization enthalpy or a low ionization energy. So what is the reason? Because of its large size. I already told alkali metals are bigger in size compared to other block elements. So based on that concept, even alkali metals have low ionization enthalpy compared to the other block elements, like compared to P block elements or F block or D block. Okay, so alkali metals have low ionization enthalpy. This concept is very important. Okay, so I have marked here. So alkali metals have low ionization enthalpy. What is the reason for low ionization enthalpy? Because of the large size. Now I already explained what is the meaning of what is the definition of ionization enthalpy. It is nothing but a amount of energy is required to remove the outermost electron. Okay, outermost electron from the outermost shell. So here what happened, since alkali metals have a larger size, so the distance between the center of the nucleus and outermost shell it is increases. So holding capacity, it becomes weak and weak. Okay, holding capacity, it becomes weak and weak. So see here I have written as a valence electron is loosely bound to the nucleus. So valence electron or last electron which is present in the outermost shell is loosely bound to the nucleus, so that we can remove electron from the outermost shell. We can remove easily electron from the outermost shell. So that's why alkali metals have low ionization enthalpy in general. Okay, so when I talk from top to bottom, lithium to francium. Okay, usually we are explaining the properties from lithium to cesium, since francium is a radioactive element. Half-life time, okay, it is very less, only 21 minutes. So we are explaining only all these properties with respect to lithium to cesium. Okay, so lithium to cesium, what happened? Atomic sizes increases. So as atomic sizes increases, what happened? The removal of electron from the outermost shell, it becomes easier and easier. So less amount of energy is required to remove the outermost electron as we move from lithium to cesium. So based on that concept, ionization enthalpy for group 1 elements or for alkali metals down the group, it is decreases due to increase in atomic size. Okay, so I hope you understood. Okay, if I consider ionization enthalpy of group 1 elements and group 2 elements. Group 2 means it is nothing but alkaline earth metals. Okay, so here what happened, ionization enthalpy of group 2 element is it is a more compared to group 1. Okay. Now next property, it is called as a hydration enthalpy, or the one more point you can keep it in your mind. Okay, that is ionization enthalpy. Ionization enthalpy, I have written in the form of IE, is inversely proportional to size of cation. Okay, size of cation. Okay, size of a cation. That means as size of cation is increases, okay, ionization enthalpy is decreases, or as size of cation is decreases, ionization enthalpy is increases. So vice versa, inversely proportional to each other. Size of cation increase ಆದರೆ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಒಂದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ, ಇನ್ನೊಂದು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಸೊ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಈಚ್ ಅದರ್. ಸೊ ದಿಸ್ ಪಾಯಿಂಟ್ ಯು ಕ್ಯಾನ್ ಕೀಪ್ ಇಟ್ ಇನ್ ಯೋರ್ ಮೈಂಡ್ ಆ್ಯಂಡ್ ಯು ಕ್ಯಾನ್ ಸಮ್ವೇರ್ ಇನ್ ದ ನೋಟ್ಸ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಡೌನ್. ದಟ್ ಈಸ್ ದಿಸ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಇಟ್ ಈಸ್ ಈಸಿ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸೈಜ್ ಆಫ್ ಅ cation. Okay, now hydration enthalpy. Now what is the meaning of hydration enthalpy or hydration energy? Now here, first I will explain what is the meaning of hydration. Okay, now hydration means it is nothing but a substance combines with the water. Okay, hydration word itself, it defines water. Hydration means it is nothing but a water. Okay, so it is a hydration reaction is a chemical reaction. Hydration reaction is a chemical reaction in which substance combines with water. Substance combines with the water. Okay, so suppose if I take alkali metals, if I take sodium, this is a sodium, it will combine with the water molecules like this. Okay, sodium cation will be surrounded by water molecules this way. Okay, this way. It is surrounded by water molecules. So this is called as a hydration. This process is called as a hydration. Okay, the energy required for this process is called as a hydration enthalpy or a hydration energy. Okay, so I will repeat it again. So what is the meaning of hydration? Hydration reaction is nothing but a chemical reaction in which substance combines with which one? Combines with the water. So this process is called as a hydration. This process is called as a hydration. Okay, so the energy is required for the hydration is this process is called as, or energy is involved in this process is called as a hydration energy or a hydration enthalpy. This is very important concept. Okay, usually question will be asked like this, give reason. Alkali metals have low ionization enthalpy. So what is the reason? Because of its large size. Okay, hydration enthalpy. Hydration enthalpy, now first I will explain the concept, then how question will be asked I will explain later. Okay, now here lithium has a high hydration enthalpy. Now why? See here also I will write down the one concept, hydration enthalpy. Hydration enthalpy I will write as a HE. Hydration enthalpy is inversely proportional to, again, size of cation. Okay, like this you can remember, hydration enthalpy is inversely proportional to size of cation. That means as size of cation is increases, hydration enthalpy is decreases. As the size of cation is less, its hydration enthalpy is more. Size of cation is less, its hydration enthalpy is more. Okay, I will repeat it again. Size of cation is less. ಒಂದು ವೇಳೆ ಕ್ಯಾಟಿಯಾನ್ ಸೈಜ್ ಕಡಿಮೆ ಇದೆ, ಅದರದ್ದು ಹೈಡ್ರೇಷನ್ ಎಂಥಾಲ್ಪಿ ಏನಾಗಿರ್ತದೆ? ಜಾಸ್ತಿ ಆಗಿರ್ತದೆ. ಇಟ್ ವಿಲ್ ಬಿ ಮೋರ್. ಓಕೆ, ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆನ್ ದಟ್ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ಇನ್ ಯೋರ್ ನೋಟ್ಸ್. That is, hydration enthalpy is inversely proportional to size of cation. So based on that, now lithium. Okay, since lithium is the smallest size, lithium has the smallest size. So based on that, lithium has a high hydration enthalpy. So lithium cation has a high hydration enthalpy. Hydration enthalpy. Okay, has a high hydration enthalpy. Why? What is the reason why lithium has a high hydration enthalpy? Because it is a smallest cation, because it is a smallest cation. Okay, so question may be asked, that is, which alkali metal has a highest hydration enthalpy? Which alkali metal has a highest hydration enthalpy? So which alkali metal? That is a lithium. Okay, lithium, and simultaneously one more question may be asked, that is, give reason lithium cation has a high hydration enthalpy. Give reason lithium cation has a high hydration enthalpy. So what is answer? What's supposed to write? Due to a smallest size, due to smallest size of lithium cation, it has a high hydration enthalpy. So please student, all these points you should note down in your notes. All these questions will be asked in your board examination as well. This is very important even for the NEET or JEE competitive examination. Okay, so all these points you should write in your notes. It is helpful for you. Okay, so now that is generally I explained. Now down the group, what happened down the group? Now down the group, since sizes increases, of course hydration enthalpy is decreases. Okay, down the group hydration enthalpy is decreases. Why? Because size of ion is increases. Okay, size of ion is increases. Now since lithium has a high hydration enthalpy due to its smaller size, lithium salt exists as a hydrated salt. Usually lithium chloride, it is always in the form of a hydrated salt. So here you can see, okay, lithium chloride always it is combined in the form of a water, so it is in the form of a hydrated salt. Why? Because it has a high hydration enthalpy. High hydration enthalpy. Okay, then since hydration enthalpy down the group it is decreases, what happened? That is sodium chloride, potassium chloride or cesium chloride has no capacity to combine with the water, has no capacity to hold the water. Okay, and then what is the next property? That is density. Density. So this is also a very important concept. Now alkali metals have low density. Alkali metals, generally alkali metals have low density. So so this point is very important. Okay, alkali metals have low density. What is the reason? Because of its large atomic size. As atomic size is increases, density is decreases, because volume is increases. Okay, because volume is increases. So this point you should keep it in your mind. Give reason alkali metals have low density. So usually question will be asked for 1 marks. So what is the reason? Because of their large atomic size. Okay, now melting point and next property, melting point and boiling point. Okay, now alkali metals have low melting point and low boiling point. Alkali metals have low melting point and low boiling point. Can you think what is the reason? Now what is the meaning of melting point and boiling point? That you first understood. Okay, melting point and boiling point means it is nothing but while heating. Okay, while heating the alkali metals, what happened? Bond will break. Bond will break. Now here in the alkali metals, only one electron is present in the outermost shell. Okay, only one electron is present in the outermost shell. That's why it is written like this, NS1. Okay, so only one electron is present in the outermost shell. So since one electron is present in the outermost shell, it has a weak metallic bonding. Okay, it has a weak metallic bonding. So it is easy to break the bond. It is easy to break the bond. So only less temperature, only low temperature is enough to melt the alkali metals or boil the alkali metals. Since francium is in a liquid state, that's why we are using as a boiling point term. Francium is in a liquid form. Other salts are in the form of solid. Okay, now so This is a reason. So what is the reason for the showing a low melting point or boiling point? Because since only one electron is present in the outermost shell, okay, so it shows a weak metallic bonding. It shows a weak metallic bonding. So it is a less amount of temperature is required to break the bond. That's why it shows a low melting point and a low boiling point. Now down the group means, of course, from lithium to cesium. Okay, down the group melting point is decreases. Why? Because size is increases. Down the group sizes increases, so attraction between outermost shell and the center of the nucleus, it becomes weak and weak, so easily we can break the bond. Okay, easily we can break the bond. And if I compare with the group 2 alkaline earth metal, usually group 2 elements have a higher melting point and a boiling point than the group 1 elements. Okay, so here all the points have written. You can see the slide, read it properly, see the slide. Okay, whenever if you want to read the slide, do one thing, pause the video and read the concept. Okay, so the next color, next property, flame coloration. Next property, it is a flame coloration. Okay, now here in the flame coloration, while heating the alkali metal, what happened, I already told, since only one electron is present in the outermost shell, okay, it will jump from one level to another level. Okay, and in the higher level it is not stable, so it will come back. So while coming back, it will emit radiations. Okay, so while coming back, it will emit radiation. Suppose if I take, this is a lower level, electron is present. So while heating, okay, this electron will jump from one level to another level, like this. It will jump from one level to another level. But here it is unstable, so it will come back. It will come back to the original level. So while coming back, what happened? This will emit radiations. Okay, this I already explained in the structure of atom concept. This will emit radiations. This emitted radiations, it look like in the spectrum or colored formation. Okay, so while heating, what happened? You can see the color on the flame, color in the flame. Okay, so different colors it is written. So this is very important concept. Question will be asked. Okay, that is usually about lithium, sodium, potassium. So many times questions are asked about this. That is name the color for the lithium when it is heated in on a flame. So it is a crimson red. Same way, name the color sodium imparted on the flame. Okay, that is a golden yellow. Same way, potassium violet, rubidium red violet, cesium is a blue. Okay, so here in the picture you can see the flame coloration. Different colors are obtained while it is heating. So lithium, it is crimson red. So this is a crimson red. Okay, so crimson red, here it is. Then golden yellow color. This is pale violet. Okay, sometimes it is also called as a lilac, rubidium, so violet. Okay, so cesium, bluish, sky blue. Okay, so you can see the different colors. So color formation is also very important for the sake of exam. Usually question will be asked for 1 marks. Okay, so you have to by the column table. Okay, this part you have to buy it. Okay, yeah. So the next, photoelectric effect. Now francium, since it is a radioactive element, does not give flame coloration. Okay, that you should keep it in your mind. So only from lithium to cesium. Since francium is a radioactive element, it does not give any flame coloration. So next property is the photoelectric effect. So this concept I already explained in the structure of atom. Photoelectric effect means here what happened when light energy falls on the surface of the metal, immediately that metal eject or emit electrons. okay, emit electrons. That concept is called as a photoelectric effect. Now here alkali metal shows a photoelectric effect. Now why it shows a photoelectric effect? Because alkali metal has a low ionization enthalpy. Okay, since alkali metal has a low ionization enthalpy, when light falls on the surface of the alkali metal, they emit electrons easily. Okay, even just light from the sunlight, okay, sunlight is falls on the surface of the metal, immediately that metal will emit electrons. Okay, so this is only because of the low ionization enthalpy. Why ionization enthalpy is less? Because since addition of shells takes place, and the bond between, or force of attraction between center of the nucleus and outermost shell, it becomes weak and weak. Okay, because it has a largest size. So because of this reason, usually alkali metals, that especially cesium, it is used in a photoelectric cell. Okay, photoelectric cell. Now the next one, appearance, how it looks. Okay, appearance, how it looks. Now alkali metals are silvery white and soft and light metals. Now here lithium is the lightest metal. Okay, so I already told that alkali metals have a low density, so based on that concept, lithium is a lightest metal. So you should keep it in your mind. This may be useful for you for a competitive examination purpose. Okay, so appearance, you can see the picture of the metal, alkali metal. Okay, so it is alkali metals are silvery white, soft and light metals. Now chemical properties, we'll move on to the chemical properties. Till now I explained physical properties, electronic configuration, atomic radii, ionization enthalpy. So what is ionization enthalpy concept of alkali metals? It has a low ionization enthalpy because of the largest size. Density, alkali metals have low density. Okay, because of the larger atomic size. Hydration enthalpy I explained. What is the meaning of hydration? Hydration means it is nothing but a substance will combine with the water. This process is called as a hydration. So for this energy is involved for this reaction is called as a hydration enthalpy. So hydration enthalpy is inversely proportional to size of cation. So based on that concept, lithium has a highest hydration enthalpy. Lithium has a highest hydration enthalpy. So all these are very important points. Okay, and easily you can score marks from this chapter. Easily you can score marks from this chapter. Okay, now chemical properties. Now what are the chemical properties? First, now I already told that alkali metals are highly reactive. Alkali metals are highly reactive. That's why alkali metals does not exist in a free elemental state. Okay, free elemental state, but it always exists in the form of a combined state, like ore, minerals. Okay, so alkali metals are highly reactive due to lower ionization enthalpy. What is the reason for the highly reactiveness of the alkali metals? Due to low ionization enthalpy. Okay, the reactivity is decreases down the group. Reactivity is the reactivity is increases down the group. Okay, so I made a mistake here. Reactivity is increases down the group. So here I made a mistake. It is not decreases, because as we move down, ionization enthalpy is decreases down the group. So based on that concept, reactivity is increases down the group. Okay, so first one, reaction with water. Now what happened? Reaction with water, reaction with air. Okay, now while reacting with the air, that is, we have written as a metal plus O2. M means it is nothing but a metal. Metal means a alkali metal. You can consider as a, so M means it is nothing but a, it is written like this. M means it is nothing but a alkali metals: lithium, sodium, potassium, rubidium, cesium. Okay, like that, metal. So generally I have written as alkali metals, metal, M. So M, when it is react with oxygen or air, means we are considering as oxygen. So metal oxides are formed. Okay, metal oxides are formed. Now in this, see, once metal oxide is formed, you can see here M2O. Okay, the formed metal oxide, it will react with water. Okay, react with water if it is a moistured air. If it is a moistured air, it react with the water. So what happened? Metal hydroxide is formed. Okay, metal hydroxide is formed here, MOH. Metal hydroxide is formed, and this formed metal hydroxide, when it is react with the carbon dioxide, metal carbonate is formed. Metal carbonate is formed. Okay, so here in the second equation, okay, in the second equation, while formation of metal hydroxide, what happened? Hydrogen gas is released. Okay, hydrogen gas is released. So that means during evaluation of hydrogen gas, high amount of energy is released. So reaction with the moistured air, it is a violent reaction. It is a violent reaction. Explosion will take place. Okay, explosion will take place. Violently react with the, okay, violently react with the moistured air, usually alkali metals. That's why alkali metals are preserved under kerosene. Preserved under kerosene. You can't keep it on the table or on the glass like that, because immediately it will react with the moistured air and it will make a sound. Okay, so it is very dangerous because it is highly reactive. Okay, so that's why it is preserved in preserved under kerosene. Okay, ಸೀಮೆಎಣ್ಣೆಯಲ್ಲಿ ಪ್ರಿಸರ್ವ್ ಮಾಡಿ ಇಡ್ತಾರೆ. Now see, the thing is, on burning lithium, usually lithium forms only monoxide. Lithium forms only monoxide. Sodium forms monoxide as well as peroxide. Okay, see, formula, oxide formula is given, and even other alkali metals forms a superoxide, MO2. Okay, so this is about the reaction with the air, and air means nitrogen also comes. So only lithium react with the nitrogen to form nitrides. Rest of the alkali metals will not react with the nitrogen. So only lithium react with the nitrogen to form a nitride. Okay, so reaction with water. So here all alkali metals react violently with water. So reaction with water, I already explained. All the alkali metals react violently with water. So reactivity increases from lithium to cesium. Okay, so hydroxides are formed. So during that time, what happened? Hydrogen gas is releases. You can see here hydrogen gas is releases. So high amount of energy is also released. Okay, during that, while releasing, while evolving hydrogen gas, high amount of energy is also released. Okay, high amount of energy is also released. So this makes a sound reaction. Okay, so because of this, we are saying that it is violently react with the water. Okay, so based on that, see here you can see the picture. Okay, so how it reacts. So it is a reactivity towards air and water. Okay, so they usually alkali metals normally kept in a kerosene oil. See here, kept in a kerosene oil, preserved in a kerosene oil. So this is very important question. Give reason. Alkali metals are preserved in a kerosene oil. Why? Because of the high reactivity of alkali metals towards air and water. Because of the high reactivity of the alkali metals towards air and water. Okay, and even because of this reason, we can't hold in our hand. Okay, with the gloves only we have to touch the alkali metals. Otherwise, we can't touch. It will burn our hand. It will burn our hand. Okay, so the next reaction is reaction with hydrogen. Now alkali metals react with hydrogen usually at 673 okay Kelvin, but lithium, it requires a temperature about, see, high temperature is required 1073 Kelvin. Okay, so here it is 1073 Kelvin to form a hydrides. Okay, so that's why lithium hydride is a most stable hydride. Lithium hydride is a most stable hydride. Okay, and all the alkali metal hydrides are, since it is an ionic solid, it has a high melting point. Okay. Now reaction with the halogens. Reaction with the halogens, usually alkali metals react vigorously with the halogen to form a ionic halides. Now here you can see the general formula I have written. M means it is nothing but alkali metals, so Mx is formed. That means lithium chloride or lithium fluoride or sodium chloride, sodium bromide. Now halogens means it is, see here it is given fluorine, chlorine, bromine, iodine. All these are halogens. You can combine with the alkali metals, so you will get this product: lithium chloride, lithium fluoride, sodium chloride, sodium bromide. Same way rubidium chloride, rubidium bromide, like that. Okay. Now the one thing is lithium fluoride. About lithium, usually all alkali metal halides soluble in water. Okay, all alkali metal halides are soluble in water, but the lithium fluoride, it is insoluble in water. Lithium fluoride is insoluble in water. Okay, because of its size. Lithium is also smaller size. Even fluorine also has a smaller size. Because of its smaller size, it has a high lattice enthalpy. Anyway, the definition of lattice enthalpy I am going to explain in coming chapter. Okay, so this is a reason, that is lithium fluoride is insoluble in water due to its high lattice enthalpy. Okay, so lattice enthalpy means it is nothing but since lithium and fluorine its size is very smaller, it is the bond between lithium and fluorine, the bond between lithium and fluorine, it is very strong. It is very difficult to break the bond. The bond between lithium and fluorine is very difficult to break the bond. Okay, so that's why high lattice enthalpy, it has a high lattice enthalpy. Lattice enthalpy means it is nothing but amount of energy is required to break the bond. Okay, that is the definition of lattice enthalpy. Amount of energy is required to break the bond. But in the case of lithium fluoride, since both the elements are very small in size, the bond between these two are very strong, so it is very difficult to break. That's why it is less soluble in water. Okay, so same way cesium fluoride. Okay, cesium iodide. Now cesium has a largest size. Even iodine also has a largest size, bigger in size. Both are bigger in size. Okay, even this is also low solubility in water. Okay, low solubility in water due to smaller hydration enthalpy. Because its size is bigger in size. Okay, this is about the alkali metal chlorides. Usually all alkali metal halides are soluble in water. Only lithium fluoride and cesium iodide is insoluble in water. What is the reason for this? Lithium fluoride, why lithium fluoride is insoluble in water? Because it has a high lattice enthalpy. Okay, lattice enthalpy. What is the meaning of lattice enthalpy? Amount of energy is required to break the bond. So lithium and fluorine, since it is a smaller element, it is very difficult to break the bond. That's why it has a high lattice enthalpy. And in the case of cesium iodide, even cesium iodide is also less soluble in water because of smaller hydration enthalpy. Now smaller hydration enthalpy, why it has a smaller hydration enthalpy? Because its size is bigger in size. Okay, that's why it has a smaller hydration enthalpy. These questions are very important. Question may be asked, and even this is very important for your competitive examination also. Okay. The next one, it is a reducing property. Next one, it is a reducing property. Now reducing property. Usually alkali metals are very strong reducing agent. Okay, alkali metals are a very strong reducing agent. Now what is the meaning of reducing agent? Now reducing agent means the substance which has a capacity to donate electrons. Substance which has a capacity to donate electron. Suppose the sodium. Sodium, it has a capacity to donate how many electrons? 1 electron, because in the outermost shell it contains only 1 electron. So 1s2, 2s2, 2p, 6, 3s, 1. Atomic number is 11. So 1 electron is present in the outermost shell. This is easily removed from the outermost shell. So if I remove 1 electron, it will form a sodium cation. Okay, so this is called as a reducing property. Now here alkali metals are a stronger reducing agent because it has a low ionization enthalpy. Okay, easily it will donate electrons, lose electrons. So based on that concept, actually if you move from top to bottom, cesium has to be a strongest reducing agent, but it will not happens like that. Cesium is not a strongest reducing agent. Lithium is the strongest reducing agent. Okay, lithium is a strongest reducing agent. This is very important question. Which one is the strongest reducing agent in an alkali metal? Reducing agent. Now why? Because now here reduction part we are explaining with respect to cation, formation of cation. Now cation is forms in the aqueous solution. Cation forms in aqueous solution. Okay, so now here what happened? So in aqueous solution, lithium will its electrode potential value is less. Okay, so based on that reason, lithium is the strongest reducing agent. Okay, so lithium in reducing properties also explain based on the electrode potential value. This electrode potential value, this term we are going to study in a second year. So for a time being, you just remember that lithium is a strongest reducing agent. Lithium is the strongest reducing agent because reducing agent we are explaining in the aqueous solution. So in the aqueous solution, its electrode potential value is very less. That's why it is the strongest reducing agent. But this question is very important. Okay, so I have written as a star mark. Name the strongest reducing agent of alkali metal, that is a lithium. So the next one it is, now reason for the anomalous properties of lithium. What is the meaning of anomalous properties? Now here anomalous properties means it is nothing but a deviation of the. Now what is the meaning of anomalous properties? Anomalous means it is nothing but a deviation or a change from. Okay, change from. So now here lithium shows few different properties compared to other alkali metals. Even though it comes under alkali metals, few properties are different from other alkali metals, the rest of the alkali metals. Now what is the reason for this? Why it shows a different behavior? Why lithium shows a different behavior from other alkali metals? Okay, so this is called as anomalous properties. Now what is the reason for anomalous properties of lithium? Actually lithium is exceptionally smallest size. Okay, smallest size in its atomic state and ionic state. Then second one is it has a high polarizing power. Polarizing power means it is nothing but a charge by radius ratio. It has a high polarizing power, and even it has a high ionization enthalpy. That is also one of the reason. Okay, high ionization enthalpy. Now because of three reasons, it shows anomalous properties. Okay, or it shows it is different from other alkali metals. This is very important question. Give reason for anomalous properties of lithium. Okay, so what is the reason? You should write smallest size. Second one is a high polarizing power. Third one is a due to high ionization enthalpy. Now what are the different properties? That is I already told why the few properties are different from the other alkali metals. So what are those properties? So that means difference between lithium and other alkali metals. At least 4 points, keep it in your mind. So usually question will be asked for 3 marks. Okay, be safe side, you read 5 points. Okay, now the first point. What is the first point? Lithium is much harder than the other alkali metals. Actually alkali metals are soft metals, okay, but compared to lithium is harder and lightest metal compared to other alkali metals. Why it is harder? Because it's a smaller size, okay, and its melting point and boiling point are higher. Now what I told, alkali metals usually it has a low melting point, okay, low melting point and boiling point, but lithium has a high melting point and a boiling point because of its lowest smaller size, okay, and lithium is least reactive among alkali metals, okay. Now usually alkali metals are high reactive, okay, but lithium is the least reactive because of the smallest size, outermost electron which is much closer to the nucleus, so it will not leave from the outermost shell. That's why it is least reactive. And lithium is the strongest reducing agent among all the alkali metals, okay. Now on the combustion with air or burning with air, usually lithium forms only monoxide, but sodium forms peroxide, okay, and other alkali metals forms a superoxide, but lithium forms only monoxide, and lithium forms nitrite. Other alkali metals, it will not react with the nitrogen to form a nitrite, only lithium forms a nitrite, okay. And then lithium chloride, okay, or lithium halide. Lithium chloride crystallizes as a hydrate because it has a capacity to hold the water, okay, because due to its high hydration enthalpy. Lithium has a high hydration enthalpy. Because of this reason, lithium chloride has a capacity to combine the water, so it always in the form of a hydrated salt, okay. Lithium chloride always in the form of a hydrated salt, whereas other metal chloride do not form any hydrates, whereas other alkali metal chloride do not form any hydrates, okay. Then lithium hydrogen carbonate. Lithium hydrogen carbonate means actually it is a lithium bicarbonate. So I will write it on the formula: lithium hydrogen carbonate, okay, lithium hydrogen carbonate or lithium bicarbonate. Lithium hydrogen carbonate or lithium bicarbonate is usually does not exist in the form of solid state, okay, but the rest of the other alkali metals, okay, that is generally I will write MHCO3, that is from sodium, potassium or rubidium, cesium, okay, all these are exist in the form of a solid, okay. Only lithium hydrogen carbonate or lithium bicarbonate does not exist in the form of a solid, okay. So these are the differences. So select any 5 difference and write the 5 differences. So this is very important question will be asked, okay, maximum time it is asked. Write any 3 differences between lithium and other alkali metals. So I hope you understood this concept, okay. So the next concept is diagonal relationship. Now what is the meaning of diagonal relationship? Now diagonal relationship, see here I have see the picture, okay, you can understand what is the meaning of diagonal concept, okay. Diagonal means it is like this is called as a diagonal, okay. Now here what is the meaning of diagonal relationship? Now diagonal relationship means a few properties are similar between these diagonally related elements. Few properties are similar between diagonally related elements, okay. Now here usually the first element of the group number 1 is diagonally related to next higher member of the next higher group, okay, next member of the higher group. Okay, so that is called as a diagonal relationship. Now here lithium is diagonally related to magnesium. So see here, lithium of group number 1, lithium is group number 1, magnesium belongs to group number 2. So the properties of the group 1 element is almost similar to property of the group 2 elements. Okay, or next higher group 2 elements. So this is called as a diagonal related elements. Okay, so definition is not important anyway, it is not there in the syllabus. Just I given the information. What is the definition? It is nothing but the properties of a group number 1 element, first element, is similar to second element of the group 2, so that is called as a diagonal related elements. Okay, so lithium is diagonally related to magnesium. Lithium belongs to group number 1. Okay, group number 1, and magnesium belongs to group number 2. So its properties are almost similar. Okay, so very important question. Name the element which lithium is diagonally related. Name the element lithium is diagonally related. So what is the name of the element? Which element is diagonally related with the lithium? Magnesium. So that is very important question. Okay, so this is called as a diagonal relationship. Now I already told that is a few properties are similar. Okay, so what are those similarities between lithium and magnesium? This is also very important question. Question will be asked for 3 marks or 4 marks. So any 5 points you should keep it in your mind. Any 5 points. Okay, so it's very important concept, compulsory question will be for the final examination. So what are the similarities between lithium and magnesium? Till now we observed what is the difference between lithium and other alkali metals. Now we are observing, that is, what are the similarities between lithium and magnesium. Okay, lithium and magnesium, because it is diagonally related to each other. So what are the similarities? Why these similarities arises? Okay, this similarities arises due to their similar atomic and ionic sizes. Lithium and magnesium has a similar atomic and ionic sizes. That's why it shows similarities in properties. Okay, now what are those properties? Both the lithium and magnesium are harder and lighter than other elements in the respective group. Actually, alkali metals are soft elements, but lithium is a harder. Same way, magnesium belongs to group 2. Group 2, it is alkaline earth metal. Even alkaline earth metal is also softer element, but magnesium, it is a harder and lighter elements. Lithium and magnesium react slowly with water. Okay, because it is not highly reactive. That's why their oxides and hydroxides are less soluble in water. Maximum alkali metals. Why name is given as alkali metals? Group 1 and group 2 elements, because their oxides and hydroxides are dissolved in water, but lithium and magnesium does not dissolve in, less soluble in water. Okay, oxides and hydroxides of these are less soluble in water. Both forms nitride. Now here I already told that only lithium react with the nitrogen to form a nitride. Other alkali metals do not react with the nitrogen. So same way, magnesium also, only magnesium react with the nitrogen to form a nitride. Other alkaline earth metals will not react with the nitrogen. And lithium chloride and magnesium chloride both are soluble in ethanol. Okay, so already I told alkali metal halides are usually soluble in water. Usually soluble in water. Only lithium chloride is soluble in ethanol. Okay, alcohol. It is soluble in alcohol. So same way, carbonates of lithium and magnesium decomposes easily on heating to form a oxide and carbon dioxide. Oxide and carbon dioxide. Okay, so these are the few similarities between lithium and magnesium. Still more a few similarities are there in the textbook. You can read it. Understand the concept and recall at least 5 points. This is very important for the exam. So I hope you understood the concept. Okay, please go through the videos properly, revise important question is also have given in the notes, so find out the answer for the important questions, read that, okay, practice. So thank you very much.